When finding the square roots of complex numbers, there's a couple of formulas you can use to simplify the process. And I just want to run through where they come from. The first one is how to find cos of half an angle if you know cos of the angle itself. So you're aware that on the formula sheet, you'll be given the fact that cos of A plus B equals cos A cos B minus sine A sine B. So if A and B are both the same thing, say x, we can call that cos of x plus x is equal to cos x minus sine x sine x. So cos of 2x is equal to cos squared x minus sine squared x. Now you're aware from other work we've done that cos squared x plus sine squared x is equal to 1, for example, with the unit circle. So we can replace the sine squared x with 1 minus cos squared x if we want to, and that's what we're going to do here. There are various formulas that we can get for cos 2x, but today's one involves just changing a double angle into a single angle, or the same thing is getting a half angle when you know a full angle. So if you were to simplify that cos squared x minus a minus cos squared x, you'd get 2 cos squared x minus 1. Now I want to get cos squared x by itself here. So if I plus 1 onto both sides, that gets rid of that minus 1. And then if I divide by 2, I'm left just with cos squared x. Now I've got that up here. It's just that instead of x, I've got theta on 2, and 2x will be 2 lots of theta on 2, which we know is just theta. So this is like cos of 2x, cos squared of x, if you like. So that's going to come in handy when we do our calculations. I'm just going to jump straight to that each time. When I'm finding the square root of a number, I'm going to be halving the argument. I'm going to find the cosine of that. I'm going to jump straight to that formula. Now, I can do something similar for finding the sine of half an angle, or I can appeal to this idea that sine squared x is 1 minus cos squared x. And I'm going to do that usually. So I know what cos squared theta on 2 is, so sine squared theta on 2 is 1 minus that. This guy here is another very important thing that we're going to use when we're finding the square root of complex numbers algebraically with simultaneous equations. Now normally, we're going to end up with these two equations. X squared minus y squared equals something, and 2xy equals something. So let's give them a value now. That can be 4, that can be 3. It doesn't really matter, but there's a couple of values for them. I'm going to find what x squared plus y squared will be equal to. And the way I'm going to do that, if I call that equation 1 and that equation 2, I'm going to actually not just add them together, but add together their squares. So I'll square this, x squared minus y squared squared, plus square this, 2xy squared is equal to 4 squared and 3 squared. So this, if I expand it the normal way, is x squared minus 2x squared y squared plus y squared squared. This is 4x squared y squared, and this will be 25 in this case. But I'm going to leave it for the point of demonstration as 4 squared plus 3 squared. Now, these two guys here are going to work together to give me x squared squared plus 2x squared y squared plus y squared equaling this 4 squared plus 3 squared. And as we know, this is just a squared plus 2ab plus b squared. So that's going to be x squared plus y squared squared equaling the 4 squared plus 3 squared. So it'll be x squared plus y squared equals the square root of 4 squared plus 3 squared. Now, what is going to be made clearer when we do some examples is this 4 and this 3 that I've let these things be equal to here will actually be the real part and the imaginary part. So when you square them both and take their square root, as we've done here, you're in effect taking the mod of z. So just quickly, if you have, that's your imaginary axis and your real axis, so you've got your complex plane, and you have some number such that you go across 4 and up 3 to there, so that's the point 4, 3. That's representing 4 plus 3i. And we know that the mod of that will be the square root of 4 squared plus 3 squared. Right? The mod of that there will be the square root of 4 squared plus 3 squared by Pythagoras. And that's what I've got down here. So that's going to come in handy. You need those two little tricks and the x squared plus y squared trick when doing simultaneous equations to make life a bit easier. So bear them in mind as we move on.